Look at the top of the paper with me, but very shortly you're going to feel like you want to start doing this. And like I said, we're going to kind of do it together, but look at the top of the paper. A little reading that we can do together, because many times real world data can be modeled with equations. Okay, when you graph points on a scatter plot, the relationship is going to be able to be more obvious. And the process, now this is the key sentence here, the process of fitting your data is known as a regression. That's like the fill in the blank. You can write the word regression. Make sure you know why you're writing that. Again, the process of fitting your data is known as a regression. Now, kids, you've done regressions before. You did them in Algebra 1, I'm sure. You would have graphed some points that were on a straight line, and then probably you got out a ruler and you drew the line of best fit. If you didn't do that, you're really deprived. And so you can kind of like imagine that you had points and you got out a ruler and you drew the line of best fit. Today, you're not going to get out a ruler to draw the line of best fit. You're going to get out a sine wave. You're going to get out a sine wave to draw the line of best fit, because your line of best fit is going to be, and this is like the next sentence, your line of best fit, it's not going to be linear, it's not quadratic, but it's going to be sinusoidal. Sinusoidal doesn't mean there's something wrong with your nose. It's just an adjective for a sine wave that fits your data. Okay, now what kind of data is going to be like a sine wave? I mean, we've seen a couple times now a circle that spins around, but how about some data that just goes up and down? Data that goes up and down, honestly, the most popular set of data would be like temperatures. And if you've looked at this first problem, I want you to notice that, yes, they are temperatures in the greatest sports city, Philadelphia. So we finally got a win. Yeah, but we also have temperatures that we're going to graph today. Okay, now listen, take 1 or 2 minutes and just, I'm not going to play any music, but just graph those points. And then we'll get down and dirty and do some math. But you need to plot those points. Mm-hmm. Try to get as close as you can. Obviously, some of the decimals, nobody's going to know exactly if you hit it on the nose, but as you do graph the points, say to yourself sinusoidal, okay, because the data goes up and down. Now, in all seriousness, the points that you're plotting, they're not perfect. In other words, they're not a perfect sine wave, and that's okay, because what we're going to do is a regression. We're going to come up with the best fit. It's not a perfect fit. It's just going to be the best fit. Which, after you plot the points, it doesn't hurt to try to draw that best fit. Now, everybody's drawing is probably going to be a little different, But just with your human observation, to try to draw a curvy line that appears to be kind of like a sine wave that would go through these points might look, something like that. And again, I just kind of put my pencil to the paper and just kind of went for it. Just draw it. I'm going to teach you how we can be a little bit more mathematical to come up with the equation for that black line. That's really what we're trying to do. We're trying to get an equation for that black line. Okay, now some of this should sound like and feel like the Ferris wheel problem. Okay, but since we have data points, maybe we have to make some adjustments to the way that we think. And that first adjustment is going to come when we do the amplitude. Now we know the amplitude is like a measurement from the middle. Okay, but since I kind of have this graph that's kind of loose, I want to recall with you a formula for the amplitude that we actually haven't really used, but you may remember that you wrote it down back on like day one. It's really nice. It's a formula. It says max minus min divided by 2. And that's a formula for the amplitude. Max minus min divided by 2. If you take the maximum temperature, 86, and you subtract the minimum temperature, 38, what you're really doing is getting the full distance. You're getting the full distance from the top to the bottom. So when you divide that by 2, well, you don't need me to tell you. You know when you divide that by 2, okay, you're getting half that distance. Another way to think about the amplitude. Okay, so we get an amplitude of 23.75. By the way, there's going to be some decimals during this lesson. You just kind of have to be okay with that. Sometimes we're going to do some rounding, and again, that's fine. Now you'll notice I did not go over to the graph and do anything with that 23 number. I'm simply appealing to the data, and that's an appropriate way to think about the amplitude. The period, probably one of the main things in this whole chapter. You learned in the Ferris wheel problem that the period does not need to be in degrees. Similar to this problem, the period would represent an amount of time. How much time does it take to go through a season, a cycle of temperatures? How much time does that take? 12 months, 1 year. We're going to do it in months, but it's kind of one of those things where don't think too hard, because you already know that after you go through 12 months, your cycle is going to start over, your temperature cycle. And so that's the period. Now, what I can do is I can find the K value using a formula that we have studied, 360 divided by K, but in radians. Now, we're going to do this in radians because your calculator is going to do the same thing that we're doing right now in radians. So we can take this formula, we can do it in radians, and use 2 pi over K. Now again, if you missed it, I'm using radians just because the calculator in a few moments is going to give us the same answer, but it can only do it in radians. So I want our answer to be in radians right now. Okay, but it's no problem. It just means my K value is going to be 2 pi divided by 12. 2 pi divided by 12 is pi over 6, or it's actually okay to write the decimal because, again, the calculator is going to give us a decimal. So I'm going to round that to about 0.52. Horizontal shift. Horizontal shift. I helped you with it on the Ferris wheel problem. I want you to realize that it has to do with the midline. Okay, now if you're like, should I know where the midline is? Not quite. I don't know if you just know where it is. We need to talk about it a little bit. Now, the midline could be thought of as the maximum. The midline could be thought of as the maximum, which is 86, minus the amplitude. Do you see what I'm doing here? Kind of going backwards. I'm starting at the maximum, and I'm going down by the amplitude. And if you think about it, that should get us to the midline. That should get us to 62. Now, where is 62 on this graph? Let's kind of take a look, because I hope that it looks like it's the midline. 62, right around here. I'm actually choosing to draw that midline now, because I want you to notice something. We're trying to find the shift, but the shift is always on the midline. And it turns out that that point right there looks pretty much like it's on the midline. Now, what I'm doing is I'm saying, hey, let's use that point because it's known, because it's given. Just understand, please, that the point 4, 63 is not exactly on the midline. I don't want to confuse someone. No, it's not exactly on the midline, but it's really close. And for the purpose of this regression, it's going to work nicely. We don't need to try to estimate something else when we already have that point. Okay, so the midline's at 62, but that point is really close. And so what that means is that we shifted 4 to the right. And again, the reason it's 4 is because that point is on the midline. Now remember, there's a formula that says that the shift is equal to C over K. And that means that 4 is going to equal C over 0.5. It's going to come out to be a decimal. Okay, this was kind of like what was going to happen with the skills that we learned a couple weeks ago. We're now using these skills to get some actual kind of real world numbers. All right, now the shift involved the midline. Interesting, the vertical shift also involves the midline. In fact, the vertical shift is the midline. And since we kind of said that we're going to use 62 as our midline, then I can use that as my vertical shift. Okay, in other words, to stay consistent. So we'll use 62.35. Now, in case you missed it, what we just did was a regression. But I don't mean that in a sarcastic way. Like, we just did a regression. We actually came up with an equation. We came up with an equation for that line that we drew. But we kind of did it by hand. We did it with like a human estimation. But you're going to find out it's not bad. It's not bad at all. You can take the amplitude, you can plug it in front of sine. You can take the k value times x. Okay, and we're continuing to plug in all these numbers that we found so that we can have an equation. And again, when you get an equation, that's called a regression. Now, what I want to show you, and just so you know, this is not like just kind of fluff and stuff, but I want to show you that we can also get this equation using our calculator. Okay, just so you know, what's going to happen here is we're going to do the same thing. We're just going to do it with the calculator. But the cool thing is that we're going to get like the same answer. Okay, well, it's going to be very similar. Now, I have these steps on your paper, but they're kind of written in just like 2 sentences. You're going to feel like we do a little more than 2 sentences worth of steps. But underneath the thing that says actual regression, there's a couple like arrows and a little check mark. You know, it actually takes you through these steps. Okay. Now, the first thing you want to do is you want to go to the stat screen. Now, the stat screen might be a place that you haven't been for a while. Maybe you've never been there. Okay, but the stats screen is where you type in statistics. In this case, we're typing in some data. Now you go to Stat Edit, and when you go to Stat Edit, this is sort of like the magical place to be. You get some columns. Now these columns should be labeled L1, L2. If they're not labeled that, maybe you'll have to get my attention after we go through this and we can fix it. So I go to Stat Edit, I have L1, L2. Now there might be some data in there from like another student, or maybe from something you did last year or just last week. But you need to delete that data by pushing the delete button and basically deleting those data points. Okay, so that you can type in our data points and just type them in. You're typing in the 12 months in L1. So L1 should be 1 through 12. And then L2 is going to be those temperatures. And again, just type them in. Just in case you're wondering, the skill that I'm trying to show you here, you are going to need to know how to do this, like for a grade. Okay, it's not going to be on a test. But it is going to be something I want you to be able to do in assignment form. When you type in these temperatures, try not to mistype. It's usually the only reason you get the wrong answer. You just mistype some data. Everything we're going to do in the next couple minutes, we actually already did on paper. We're just getting the calculator to do it. Okay, some of it is obviously just pushing the right buttons. Now, the data's in the calculator. It would be nice to see the scatter plot. Even though you already graphed it by hand, why don't we tell the calculator to show us the scatter plot? And so we have a couple buttons we need to push. Mainly, we have to turn on the scatter plot. How do you turn on the scatter plot? Go to second y equals. Go to second y equals and choose or select plot 1 and basically turn it on. So choose plot 1 and toggle until it says on. You'll notice there's some other stuff in this screen that should make sense, like we're doing a scatter plot. Our data is in L1, L2. I'm going to let my little mark look like a box. I mean, you could change it if you want. So we basically turned on plot 1. Now there's one other thing, it's the window. It's kind of the part that students don't like, I think, because sometimes you have to think. But your window is like the same as the one I gave you on paper. If you look at the x-axis on paper, it went from approximately 0 to 14. So you could graph those 12 months. If you look at the window on paper, the y-axis went from about 30 degrees to 80 some degrees. I'm going to go from 0 to 100 because I like to see 0. And I'm going to go to 100 because I can. I can go a little higher. Obviously, the calculator can do whatever we tell it to do. So we're changing our window to match the data that you graphed. And sometimes that's a little sticky point for students. They're like, what's the window? Okay, the answer is think about the data. What kind of data do you have? And like I said, I started at 0 just because I like to.
Is there a way to reset back to the original window?
You can reset anytime you want by hitting Zoom 6 or Zoom 7, because all that Zoom thing is doing is just resetting the numbers. Yeah, we're overriding them right now. Okay, now cross your fingers, hit the graph button. Don't hit Zoom 7, hit the graph button. You should get a pretty picture. You didn't turn on the scatter plot.
I swear I just pressed on and then
Now your data, something's wrong with your data. You're going to have to double check. That should say L2.
are you serious?
Just highlight it and choose L2. It's second 2. How we doing? Any other calculator Okay, because in your y equals screen, you can just clear that equation.
Calculator in there that
Don't put it back in the box. Just put it on my desk, unless you forgot. Now, if you're, I'll come around, but if you're like, what else are we doing here? I want to do something. Type in your equation. Type in your regression equation that we just spent a whole bunch of time coming up with. And do you know what's going to happen here? I'll type it in and see.
I found it. Like I went to sign right here and they gave me that.
Nice job. Except, is it in radians or degrees? I think it's right. It's in radians. So the accept is that you're good.
It seemed reasonable for what I had.
Nice. You're figuring out, which I like. Oh, did that happen to you too?
I don't have like a L2. It's not.
Second two.
On L3. Okay, I'm confused.
Now, I switched it to radians because our equation's in radians, right? We switch it to radians because our equation's in radians. So that's a little fixer up there.
So I changed all my data when I did that.
Okay, you're just going to have to, I don't know. Somebody deleted L2 on this. So
Should I get a different one?
Yeah, I mean, you can still follow what we're going to do here, but next, just grab another calculator. I'll have to reset that.
I had like the same line that you had, and then I went to this and I changed it to radian, and now it's
13.75.
oh
23.75.
okay.
You owe me a quarter. All right, now, you should be looking at this saying, that's cool. Yeah, it's cool. It's also kind of shows that what we did is pretty good. Like, that pretty much fits the data. Now, you should also be looking at it saying, but it's not like fitting it maybe as well as I thought it could. Right. Okay, that's because we kind of did a human regression. The whole reason we're doing this on the calculator is to let the calculator do the regression. Ready? Stat calc. And I do have this written. I told you I have like 2 sentences written, but it seems like you're pushing a lot of buttons. But you go to stat calc, slide all the way down to C, and you get not a sin reg, but a sine regression. Now, some calculators are a little different at this point. I'm going to choose letter C. My calculator, it just lets me hit enter one more time and out pops all the magic numbers. Some of your calculators, you might have to hit enter through like an extra screen. Just kind of hit enter until it cranks away and out pops all the magic numbers. Okay, remember, it's probably just because you typed in a data point. I've done it myself. Like, you almost have to go back through all 12 of those points and see, oops, maybe you just missed like a digit somewhere. You still did the right steps. Okay, and this set of 4 numbers, are you guys realizing what they are? Okay, they are the magic equation. They are actually the correct full equation. And, well, I'm going to model for you what I would expect you to do, but simply I'm copying them down to 4 decimal places. Excuse me, 2 decimal places. I wrote the number 4 and then I said the number 4. Now, as you look at these numbers, I want you to actually say, okay, they're close. In other words, we're right. Don't look at those 4 numbers and say, oh my gosh, that's way different than what we did. No, they're close. Now, it turns out that the period, even though it's only off by like 0.8, has the biggest impact on fixing this graph. And so if you actually type in the regression from the calculator, I'm just typing over top right now. But if you type in these numbers, you'll see that your graph fits so much better. Like, it really is the best fit. Okay, but
How do I get it to make a line?
you have to type it in the y equals screen. You have to type it in the y equals screen. Okay, so obviously the calculator has a program that actually computed all these points and came up with the best fit a little differently than how we would have done it by hand, but it's a similar algorithm. All this is nice, but if you don't do anything with it, it's sort of like doesn't have a purpose. And so if you look at the bottom of the paper, I have two simple questions. One of them we kind of already answered. How do the equations compare? Again, they're very close. If you look at the second question, I'm asking you to think a little bit about May 15th. Now, May 15th is like a month. I'm pretty sure, although I have to always think of this twice, it's the 5th month, and it's halfway through the month. Just to make it simple, it would be like x equals 5.5. And so just like you've done many times in math and science classes, you could plug in. And I'm just trying to show you that your equation is really a formula for temperatures. And so I can plug in the month 5.5. It's a lot of numbers to type, but I'm basically plugging in 5.5, and I can trust that the equation is going to give me the temperature on May 15th. That's what 77, it seems a little high, but we'll go with it. 77 some degrees. So what you guys are doing here is probably one of the more practical things in a math class. That is, you're analyzing data. And if you ever wondered, what does somebody do with a math degree? It's not just that they become a teacher. I've actually had students get really excited about math, and they're like, I'm going to get a math degree. It's probably one of the most marketable degrees. I'm not just saying that because you are able to do so many things, oftentimes in like the business world where you can analyze data, you can make predictions. Somebody that's involved in like an energy company, selling gas or oil or something that heats your home, they're going to want to know kind of what the predicted temperatures are based on a regression. And even though we did this in the classroom, and you could take the equation that you have and you could then use it to make predictions for things like energy consumption and so forth. A lot of times a math degree, also a student with a math degree earns what's called their actuarial, an actuarial, or they become an actuary. They take the actuarial exam where you go 10 times deeper into statistics. I mean, this is good stuff, but there's so much more. And somebody that studies to be an actuarial can analyze data at a really high level. And maybe it's something that, if you're kind of into thinking mathematically, that you might want to consider. It's more than just a math teacher. Okay, but on the back of the paper, I'm going to ask you guys to do two other analyses. And it should stretch you a little bit. It's not just going to be like the same exact thing that I did. You're going to feel like one of the problems you're kind of doing it a little backwards. Okay, so you have to be willing to think, but you're going to use the skills that I showed you. You will use a calculator. Let me talk a little bit about next week. You have a test on Tuesday. Monday will kind of be like a wrap-up day. I will give you a review paper Monday. I will also give you back some papers that you've done over the last chapter. This paper you can also work on Monday. Did you hear that? It's not necessarily due at the beginning of the period. It's something that if you want, you could still be looking at it. I would look at something before you come in the classroom because you may want to be thinking about the test. But there might be something on this paper that you're like, I wish I could work on that in the classroom, and I'll let you do that Monday as part of kind of that wrap-up day.
Which is the target?
Tuesday, Wednesday. At this time, I'm thinking that because the periods are short, that we'll use some of that 2-hour delay to be able to finish the test. I haven't really decided what's going to happen every other time this year, but at least for this time, we'll probably do that.